This is a tutorial about mastering reusable base environments for Python. So let's say you've been playing around with AI for a while and you have many Python repositories pulled for various AI projects, and you notice that, well, almost every single one of them needs some basic modules such as PyTorch. And each of those PyTorch installations is over 2 gigs. Now, in today's storage capacity, that's not a game changer, but it is significant. If you have 10 projects like that, that's over 20 gigs of space that you're using. But on top of that, every time you pull a repo and do the installation, it takes a while because it needs to download yet another copy of PyTorch, which, depending on your internet speed and how fast it's being served, can take a little while. So there's got to be a better way. And yes, there is. Python has this ability to tell a Python environment that it should go looking for additional modules outside of that environment. This is very useful, and one of the things it allows you to do is to create a base environment where all of your reusable modules will be installed, and then to create project-specific environments that will just add on the additional modules that that project needs. But all of those base modules don't need to be downloaded over and over and over again because they're just referenced. Now, how does that work in practicality? Well, what it means is the environment that you've created is the first priority. Only if a module is not found in the environment itself will it then follow those links to the other locations of modules and see if they're available there. In addition, Python recognizes that those external locations of modules are different from modules in your own environment. And if you try to uninstall those or update those, it won't allow you to. In order to update those or uninstall those, you have to go to the environment in which they were created. So that's very good because what that means is if we now have a common base environment, we have a guarantee that a project using it is not going to modify it. Okay, so here we've got a little bit of a summary. So essentially, when Python needs to check a module version, what happens is it will look in the environment that is currently active. If it's found there, that's the version it will return. If it is not found there, it will follow the link to the alternate module's location and see if it's there. If it's there, it'll return that version. And if it's not there, then it's just going to say that it couldn't find the module. If we do a install of a new module, any installs of a new module always get installed to the active environment, not the base environment. And as we know, that's where Python looks first. So that means if you install a module that wasn't in the base environment, it's going to be available in the new environment, so you're good. If you install a module that was in the base environment, then, for example, to install a different version, again, because your new environment has priority, that's the one that Python is going to find first and use, and it's going to ignore the one in the base environment. Only if you, for example, uninstall the module from the new environment, then it'll be defaulting back to the copy that's in the base environment, or if it doesn't exist in the base environment, it's going to be uninstalled. So that's what we just discussed here. If you uninstall a module, if it's a module that is in your active environment, it will uninstall it just like normally. If it is not in the active environment, but it is in the base environment, you're going to get a basically an error message saying that the module cannot be uninstalled because any of the base environment modules are not, Python won't allow you to uninstall them because they are outside your active environment. That basically guarantees that the base environment is not modified, because there could be many other projects using it. So you want to keep that the same. If you do want to actually change your base environment, then you'd have to deactivate the current environment, activate the base environment, and then you can make modifications. And then using a module is the same thing as looking for the version. So again, Python will look through modules in the current environment first. If they're found there, that's the version it uses, regardless of whether or not it exists in the base environment. If it does not exist in the active environment, then it will go to the base environment. If it exists there, it'll use that version. If it doesn't exist there, then it's going to return back the fact that that module is not installed. Okay, so that works great. So how do we actually make use of this? So what we first do is we're going to create that base environment. So using the regular methods for making an environment, it doesn't matter if you happen to use Py, pip, or Python to create those environments. You're going to use venv to make a base environment. Then we're going to activate that environment. And then we're going to install all of those reusable modules. So the stuff that other projects are very likely to use, ideally anything reusable that's large, because that's going to save you both disk space and download time. So things like PyTorch, PyAudio, PyVision, any of those, you're going to want to install here in the base environment. This is what's going to then make sure that when other projects use it, they're going to use this copy instead of having to download their own copy, saving you disk space and that download time. Once we've done that, we're going to deactivate the environment, and then we're going to create the project-specific environment. So again, the base environment is going to be there once, but then there will be many project environments that use that base environment. Now, typically, you're probably going to have more than one base environment. I, for example, have one base environment that uses PyTorch 2.8 and CUDA 12.8. And then I have a second base environment that uses PyTorch 2.10 and CUDA 13. So different projects require different versions of PyTorch. Some don't really care, but some are very specific. So that's why you may have to have a few base environments, but still having 2 or 3 of these environments as compared to maybe 10 or 12 is still a savings. All right, so now we create our project-specific environment. Again, using the completely regular methods for creating an environment. But then before we activate it, we are going to go into the libs site packages folder of that environment. And we are going to create a PTH file. PTH file is just a regular text file, but it has a PTH extension. So you can call it whatever you like, as long as the extension is PTH. And the contents of it is going to be the full drive and path to the libs/package or site packages folder of the base environment. So what this is telling Python is, after you've checked the current environment for modules, if you don't find them there, go to this location and check there also. Okay, so once we've got that, we just save that, and now we can activate the project-specific environment. And then what I would recommend is doing a check. Typically, you can use pip show or pip list to list the modules. And what you should see there is all of the modules that you installed in the base environment should now show up in your project-specific one, even though in the project-specific one, we never installed them. So this is going to demonstrate that the modules from the base are being picked up. And that's pretty well all there is to it. This way you can make a based environment, and then include it in your project-specific one so that all of the modules like PyTorch are already included, and therefore when you run the install requirements for a project, hopefully it's going to see that those requirements are already satisfied, or at least the PyTorch ones, the ones for the base modules are going to be installed, and it will only install the additional modules that it needs. Okay, so that looks like we're done, right? Like, I mean, we have a way to link in a base environment. Everything's good. We've saved disk space and we've saved download time, so we're done, right? Well, not quite. This works great, but there is one problem that this doesn't address that we may need to address. This solution works great if you've got a repo where you do like a pip install -r requirements and it installs all the modules. For that, it works great. But a lot of projects have their own installer where instead of running a pip install -r requirements, there's a Python script that does its own installation. Now, why is that a problem? Well, that's a problem because most of those types of installation scripts create their own environment and then install stuff into it to make it easier for the user, obviously. Well, that becomes a little bit of a problem because if it creates its own environment, it's not going to create that PTH file that we created here manually, and then it's going to immediately try to install stuff. So you're going to run into the problem where any of the modules that it needs, it's going to have to download again because it has no concept of this base environment. I mean, a few possible solutions would be to edit that installation script, put a pause after it creates the environment, and then manually create that PTH file, and then allow it to resume. But that requires going into the installation script, working through it, figuring out where it creates the environment, and adding something, a pause or something like that afterwards. That's cumbersome. It's doable, but it's not straightforward. It means that every time you want to do this, you've got to go editing that installation file. So there's got to be a better way, right? And yes, there is. What we can do is we can actually go in and make a very small modification to the venv process so that after it creates an environment, it will create that PTH file for us automatically. If we do that, now if an install script creates an environment, as soon as it creates that environment, part of that environment creation process will be to create that PTH file. And therefore, when it goes to do the install afterwards, that PTH file is already going to be there, and it's already going to be aware of all the modules in the base environment. So that fixes that issue. Now, is it 100% perfect? No. It does have a few caveats. If you reinstall your Python or update Python, you're probably going to have to reapply that little modification. But in most cases, it's going to do exactly what we need it to do. So let's have a look at where we need to make that small modification to automatically create the PTH file so that we can run installers that create environments and then install requirements to those and still have the benefit of our base environment. Okay, so the update that we need to do is in the Python installation. So if you have different Pythons and you want this to apply to all of them, you will need to repeat this for each Python installation. As I said, if you update your Python, you'll probably have to reapply this, but it's not a big change to make. So I'm going to go here and I am going to go to my Python 12 installation folder. I have it here on root D. You may have it somewhere different. By default, it's probably on your Windows 11 system drive somewhere under app data. Doesn't really matter. I'm going to navigate to that folder, and then I'm going to go under lib and venv. Helps to spell it right. venv. All right, and then I am going to just edit the file called __init__dot Python. Okay, that's going to open up this large file. I mean, relatively large. Don't worry about all of this. This is all the code for making an environment and so on and so forth. We don't really need to understand the details of all this. We're just going to scroll all the way to the end. And we're going to find this section right here. So just before the check for main here, there is a create D. This is basically where it builds the environments. Normally, when you're building an environment, there's only one environment that you're building, but Python does support generating multiple environments at once, hence why this is in a loop. So all we need to do is add here the creation of that PTH file. I have done this in my other Python version here, so I'm just going to copy the code that I've got there. Again, scroll to the very end, and we can see here I've added a tiny bit of code here. So I'm just going to grab this and paste it into here. Now, I've made this a little bit more versatile. You could absolutely, in this section, just write out a hard-coded link to your base environment. I didn't do that because, as I said, I've got a couple of base environments, so I want to be able to select which of those environments I want to use. So what I have done is I've created a environmental variable called Python shared base. I can set that to the full drive and path of the base environment that I want to use. And then down here, you can see that it's going to create that PTH file using whatever the contents of that environmental variable was. So basically, before I run an installer, I can set this environmental variable to point to whichever base environment I want. And then when the installer runs and creates an environment, it's going to trip this and it's going to write this PTH file based on whatever I put in the environmental variable. So that makes it a little bit more flexible, that I have the ability before running the installation to basically choose which base environment I want to use. Again, if you only had one base environment that you were using for everything, you don't really need this. And right here, you could just hard code the location of that base environment. But this gives you a little bit more flexibility. But that's basically it. This just adds in so that every time this version of Python is used to make an environment, it will automatically create that PTH file that points back to a base environment, so that if a installation script does this, that PTH file will get generated immediately. And therefore, when that installation script then tries to install modules, it's going to already see all of those base modules there and hopefully not have to download them all over again. So that's about it. Just again, keep in mind, this needs to be done for each version of Python that you have installed, assuming you want this functionality for all of those versions. And also keep in mind that if you do an update on your Python version, then you're likely going to have to reapply this because it's going to, the update's likely going to overwrite this file and remove that. And that's about it. I know these videos don't have great production quality, but they do have a lot of useful information. So please appease the YouTube algorithm goddess by casting the subscribe spell and then blasting your Eldritch Blast at the like button. It'll really help me out.